They say things happen for a reason. They also say the good die young. Life is as fragile as a butterfly in transformation, on its journey, a fleeting, beating heart that finds its way to a new being. Maybe it's in our spirituality, but maybe nothing has rhyme or reason. Maybe that's why I can't sleep at night. Who am I? I am him, I am her, I am you, I am we. And we have seen many of our young become angels in a very short time. Many are not even correctly diagnosed with a disease so rare they call it orphan. But we are not orphans. We count. We matter. We are loved. See, there is a sickness that exists, a disease so evil, and it needs a cure. With little or no warning, it's killing our children, our teenagers, our moms and dads, our newborn child. It doesn't discriminate. It could be you. Few know what it is, even your doctors, and most can't even pronounce it. Even some of the fiercest shining knights can't always defeat it. It's called histiocytosis, and there are several aggressive diseases amongst this group. And we need awareness so we can hunt down this monster that leaves our families victims of an uncertain outcome, baffled, brutalized by watching a normal, healthy body suddenly deteriorate before their eyes. Some have months or weeks to fight, but some are only given days after their diagnosis to figure this out. You are not alone. I may be angry, other times sad. You could call me defeated and weak in acknowledging this devil. But in this fight to find understanding and a cure for a disease that has horns, our weakness will become our strength. We won't step down. Our courage will move mountains. We will climb that brick wall, and we will never stop. In this disease, there are warriors and there are angels, those who survive and the many who have passed on. But in our fight to find a cure and fight this monster, we are all warriors. We call ourselves HISTIO warriors.
histiocyte's a normal cell, develops in the bone marrow, travels through the body, is part of the immune system.
Does she have cancer? Well, no, we don't think she has cancer. Well, why do you have an oncologist here? Oncologists treat cancer.
I asked the doctor to write it down because I never heard of such thing in my life.
Okay, yeah, it's just a rash. No, don't worry about it. It'll go
Unlike
away.
anything I had ever seen. You go through life thinking that hospitals and doctors know everything.
The government, frankly, doesn't give a hoot about histiocytosis.
The answers aren't
We're a
there.
group of people who are ignored and denied and stepped on and pushed
I
aside.
think it's terrible that it's considered an orphan
You
disease.
could not assure me that everything was going to be okay.
Raise our voices up to say, hello, we are here and we need to be heard and you need to know about this because it could be your child next.
My name is Jackie and I have LCH.
I'm a warrior.
I'm a lawyer.
Not a lawyer.
Day after her birthday, she was complaining of an earache, so we took her to the doctors. At one point, blood was coming from her ear and they called it a perforated eardrum. There were no fevers before then or rashes before then. No. Nope, she never had anything like that. Scheduled an emergency MRI and we did find out that it was a cancerous tumor in her skull, and he called it Langerhans cell histiocytosis. It had consumed her skull bone, the mastoid bone in her skull. It was pressing on her brain and had broken down through her ear canal. Then the doctor explained to me that it's up for debate whether Langerhans cell histiocytosis is cancer or not, because it's treated identical to how cancer is treated.
50% of the doctors will classify LCH as cancer, 50% will say it's not cancer.
And they said that it was not communicable and that it was not hereditary, and it was something in the environment, and they don't know what. It could have been anything that her body reacted to with the white blood cells, the histiocytes, just, formed too many and formed a tumor, and that tumor consumed the skull bone. Your skull. Her tumor was growing vertically and it broke through her ear canal, so we knew something was going on. Had it been growing the other way, we never would have known. Because of its location, they didn't want to do surgery because it was pressing on the dura. Between the brain and the dura is your spinal fluid, and they didn't want to rupture that, so they decided to treat it with chemotherapy.
They put something in and then we put the special cream on so it didn't hurt.
The special cream.
And
What was the prednisone? You remember that? Did you like that one? No. And what happened? Did you eat a lot?
Yeah.
And what happened?
Cheeks were chunky.
Your cheeks were chunky? She did a combination of the prednisone and the vinblastine. She is in remission. She'll be checked every year for the rest of her life.
The likelihood of it being back, there is a slight chance, but we're hopeful that it's gone, and we just take it every day as it goes, one day at a time.
Does the doctor ask you to walk a certain way?
Yeah. On your heels and on your tiptoes.
They have her walk that way because sometimes the LCH can affect the joints, and they want to make sure that, and that's the first place they notice it is when you're walking, if the foot can stretch up and down. I don't know why it lands on skin in some children and on organs on others, and the skeletal system in others. I have no idea, and they don't know, and that's why we need this research. We need the funds to find out why. We have so many unanswered questions, and you have to stay positive, yes, and you have to have faith, but the rest of my life I'll be worried about her.
What do you want to be when you grow up? Do you know? Do you want to be a princess or a ballerina?
An actress, a dancer, what do you think?
I don't know. Maybe a doctor.
Maybe a doctor? Really?
I want everyone to get better. I'm a survivor.
Don't give up. She didn't, and we're not. We'll never give up.
No one is as motivated as a group that's been touched by a particular disease or group of diseases, and this is a particularly difficult and challenging group of diseases, and the fact that you have been spearheading fundraising for research in this disease is something that is a truly wonderful thing because it's greatly needed. Little has been known about the histiocytic disorders over the years, and I remember when I was an intern many years ago, and literally no one had a clue as to what to do with these diseases. Didn't know what it was, whether it was infectious, cancer, non-cancer, and certainly had no idea about how to approach the treatment. We understand what you are going through and have gone through. We understand that you are propelled, as we are, to identify the cause of the diseases that we're talking about here today, and that we're propelled to come up with cures.
Our purpose is to cure all of these diseases, and we really are not focused just on one, but all of the diseases that come under the umbrella of histiocytic diseases, be they Langerhans histiocytosis, the hemophagocytic syndromes, juvenile xanthogranuloma, Dorfman disease, and there are some others. But it's a very slow process. The current LCH4 protocol has been under discussion for 4 years, and that's a little bit too slow. So Dr. Allen and I are doing pilot studies to advance new ideas and try new medicines to do new things more quickly. Last year we saw 126 new patients with the various diagnoses, and we have over 400 active patients who are circulating through our clinic at various intervals depending upon where they are in their treatment program. But behind the scenes, there's a lot going on too, because every day there are phone calls from families and physicians asking for help in taking care of patients not only in Texas but around the world.
There are 3 genome sequencing centers in the United States. Okay, so there are 3 centers that were involved in sequencing the genes in the human genome. And what we're now doing is we're applying these technologies to these different types of malignancies. So we're actually able to look at what are the genes present in a specific individual's, let's say a case of LCH, and to determine, is that something unique to all patients with LCH, or are there unique genes in an individual, and which of those genes might be involved in the development of the disease, its progression, its ability to spread, its ability to resist treatment, be it chemotherapy or some other form of treatment. And that's a tool that very few people and very few institutions have. These are not rare diseases here. That may be the most important thing of all. Right. We're seeing more than a quarter of all of these diseases that occur in the United States each year. That's astounding. And why is that important? Well, for example, if you're doing gene expression studies, then and you only see 3 patients, you can make no conclusions about that data. But if you're seeing 125 patients or 126 patients, and that number is increasing, you're going to get a lot of information about a lot of patients, and then be able to do what we call molecular epidemiology, and then find out, are there unique lesions in certain groups of patients based either on ethnicity, on geography, on other epidemiology factors, tissues, getting the samples. And it's hard to think about your child as a source of tissue, as a source of blood, etc. But the fact of the matter is, you want to be able to apply every new sophisticated and complex tool that's available. You want no stone to be left unturned in making certain that your child gets the very best chance of therapy and has the very best opportunity to allow us to learn more about the diseases as a whole.
My name is Jamie McKeever. This is my wife Heidi. Our daughter Valerie, who's now 9, diagnosed a bit later, nearly 7.5 with LCH. Front of her left side on her skull. Literally over 3 weeks' time grew to golf ball size kind of lesion on the outside. Scariest day of my life, seeing the CT scan with the hole in the skull and the impingement down on the brain. So went through some diagnoses, came in. We work with Dr. Allen now, or we did, we still do, and diagnosed with LCH, tumor removed or growth removed. Went through a year of chemo and other things, and just got through with that in March. Had her port removed just last month, so that was another big step for us, and now we're kind of on the, just watching what happens here going forward, so in a pretty good spot for us, so it's good.
So this is what we do when we ask for your blood. We layer the blood over the sugar gradient, and then all the red blood cells go to the bottom. We don't really need those because they don't have any information. This yellow stuff, and it's good. I didn't eat a donut this morning, so you can see any cholesterol on the top. But the white part is all the white blood cells, and so we think this is where the LCH cells are living. And the question is, how can we figure out where they are and which ones they are? And so when we get these samples, we'll freeze the white blood cells down so we can thaw them out, and they'll still be viable later on. And then the plasma we freeze down for our proteomics studies. So we'll have basically the ability to do hundreds of experiments just from one sample. On this chip, if you look really closely, there's 50,000 or so little dots. And the computer reads those dots and says, well, how intense is each dot? And each dot corresponds to a specific gene. And then you do a different chip for each sample, and then you compare the relative intensities of those samples. And so this is what people talk about when they do gene chip experiments. And you just put it on a little scanner and it reads it. Each experiment we do costs us about $2,000. And so you get a huge amount of information, but in order to get all 1,000 samples out of our freezer onto chips, it's hundreds of thousands of dollars. But I think we've shown that at least the techniques work.
How much stuff is in here?
Basically what you can see, there's not much hidden. We've got about 4 years worth of samples tucked away. It'll take me a while to figure out which ones are yours, but I can give them back to you if you ask for them. But that's your legal right. We don't want it. But you're the reason this stuff works, so we appreciate it. You can come work for me for next summer. I can get you a job here.
Internship?
Yeah.
Internship?
Yeah, I need help filling the pipette racks. Actually, I think your blood might be in here. Stand back. It's stuck. So we just keep the boxes stored in here. And they last forever. So we have a farm of these tanks upstairs. So that's the life cycle of what happens to blood when you bring it here. We put it through there, we store it, and then we try to put it on the chips and have the information go in the computer.
There's 3 separate diseases within the group. First group having 1 or 2 lesions here and there. The second group having multiple lesions long term. The third group having an overwhelming disease and chance of not survival.
By the next month, the lesion
that pretty much destroyed my vertebrae and had to have emergency surgery. So I've since had 6 vertebrae in my neck fused because of the LCH. 6-7 weeks later, I started chemo. That was April 27th of last year. 2 weeks ago, I completed my 30th and hopefully my last chemo. My mom always said that this was brought to me for a specific reason, and I think that's what it was for us, to raise awareness.
In 2007, we published a study showing that thalidomide, which had been a scary drug, had been published to be effective in adults, and we did a trial that showed it's very effective for children as well. We reported 44 patients with LCH who had PET scans and showed how that was a very, very effective way to diagnose and follow the treatment of these patients. And for the first time, could really see healing of bone lesions that had not been measured prior. Then a trial to use another drug to improve the central nervous system problem that the LCH patients have using cytarabine. And for the first time, we're able to improve the neurologic symptoms of these patients.
So LCH is the biologic focus of our group right now, and interestingly, we can diagnose LCH extremely well. If you take a biopsy, it's LCH, no question. What is LCH? Well, it can be from just a rash that's really hard to distinguish from a normal baby rash to multiple skull or bone lesions. That can be either a single lesion or multiple. That can be rapidly developing, life-threatening with big spleen and liver. You can have lung involvement either as part of the whole disease or just as a single component. So all these various presentations, well, when we look in the microscope, I can't tell you which patient this came from because they all look the same. If it was in Boston, you'd call it Hand-Schuller-Christian disease. If we're in Europe, maybe you'd call it Leber-Seaweed, or orthopedic surgeons still call it eosinophilic granuloma. There's a form that supposedly goes away called Hashimoto-Pritzker, or just isolated pulmonary. Well, whatever the form is, it all kind of looks the same. And in 1953, there was a physician scientist who said, well, wait a minute, maybe if all these things look the same, maybe it's all the same disease. So we're just going to call all these diseases histiocytosis X. And X literally means we don't know what it is. This is an LCH lesion, and these little coffee bean shaped thing here is what we'll call for now a Langerhans cell. And all this red is actually a protein called osteopontin that we recognized recently is expressed by LCH lesions specifically. And so this just kind of shows sort of a nice little picture of what an LCH lesion looks like. And it looks a lot like this Gordian knot. So this is the knot that couldn't be untangled. Someone figured I could just take a knife and cut it, it all falls apart. So that's what we're trying to do. This thing that looks kind of like a tennis racket, it's called a Burbeck granule. And these Burbeck granules are also present in the epidermal Langerhans cells. We have these dendritic cells in our skin called Langerhans cells, and they have the same shape. So a group of French scientists says, aha, we figured it out. Histiocytosis X is caused by Langerhans cells. So henceforth, it's been trademarked Langerhans cell histiocytosis. So this is a picture of the skin here. They migrate out of the skin, they go to lymph nodes, and the lymph nodes is where they talk to the T cells, and they tell the T cells, hey, go recognize any cells that are infected with this virus and go kill them. And instead of going to the lymph node and instructing the immune system how to work, they go and form lesions in all these various tissues. The two possibilities are that you have some sort of lesion in the cell itself, whether it's some genetic rearrangement or some other hit that makes it become LCH. Or maybe this is a perfectly innocent bystander and there's some stimulus that's turning it bad. There are no animal models of LCH. There's no cell culture models. As soon as you take the cells out of their environment, they die. So one phenomenon I'm still trying to figure out is, if I get a biopsy from the OR and I disaggregate it, if I put them in a tissue culture dish overnight, 100% of the Langerhans cells will be dead in the morning. But if somebody mails me from New Jersey a lesion and FedEx mixes it up and it doesn't make it to my office for 5 days, I'll disaggregate that. If I do a flow cytometry on it that day, the cells are still alive. So there's something about the environment that's essential. The T cells and the dendritic cells, there must be some signal that's essential for them to talk to each other, but until I can figure that out, I can't study them very easily. So we went from histiocytosis X to LCH. I think we're back to histiocytosis X now, but I think what we're going to do in the next 5 years is discover that really when we're talking about LCH or whatever we're going to call it now, it's probably 4 or 5 different diseases that look, or 10 or 20 different diseases that look the same under the microscope. And we really need biology to characterize what these subtle nuances between these categories are. And then, so these are the experiments that we have to do. And if we do all these experiments, we will know what causes LCH. And not only will we know what causes LCH, we're going to do the same workflow for JXG, for Rosa Dorfman, for Chester. We're going to apply some of them to HLH as well. And this is, I think if we can do this in the next 5 or 10 years, we've estimated this would cost about $5 million to do everything we want to do. So, while we're sort of a small group, we really our dendritic cell tentacles extend very, very far.
Our youngest son, Patrick, was diagnosed in 2004. He had skin lesions and eventually developed some bone lesions. He was treated up until just 2 years ago. It'll be 2 years, August 7th, so we're pretty excited about that. That he'll be off chemo, but he was on chemo for about 16 months until pretty much age 7 on and off.
My son Evan, he's 6. He was diagnosed at 3 years old, had scalp lesions at 6 months old, and then he developed swelling around the ear. For about a year and a half, we treated mastoiditis and the ear infection, and it never went away. And then he woke up one morning and had DI, diabetes insipidus. Finally, a biopsy confirmed that he had the LCH. He did. We came here, saw Dr. McLean, did a year of Aracy, and then Christine, I believe. That cleared up the skull lesion, and then 15 months later he relapsed with a lesion on his humerus. We chose to just do the curettage, and it's been a year and he's completely healed right now, and he had a PET scan that was clean a year ago. So far, as far as I know, he's in remission right now, but I am worried about the pituitary and the future CNS degeneration and stuff like that.
Of all patients with Langerhans histiocytosis, nearly 25% get diabetes insipidus sometime, some at the beginning, some later on after their diagnosis of LCH. Bone lesions include around the eye, the ear, and the temporal bone. And there are some pathways, some little highways, more or less, where cells can move from those bone lesions into the area of the pituitary and seed those diseased LCH cells into the pituitary and cause diabetes insipidus. So that's a subgroup where we know we've got to treat those bone lesions, even if it's only one thing, that lesion needs to be treated. Once a child with LCH gets diabetes insipidus, then they have a 50% chance of getting problems with the front part of the pituitary gland, which controls our growth and development. And they also have a 50% chance of getting this neurodegenerative condition.
I guess I'm the family spokesperson. My son Taylor's 15. He has LCH. He's in the wheelchair in the family room. I'm sure everyone has met him because he loves people. There's not enough hours in the day for me to tell you everything he has been through. He was diagnosed at 13 months with multisystemic disease. Did not have much of a chance. He was very, very ill. Did a lot of chemo. He's been on and off treatment for the last 14 years, and he has CNS involvement that's pretty severe. And he is, knock on wood, somewhat stable right now, not getting worse quickly, and that's all we can hope for. We're patients of Dr. McLean's, and they have a quite unique relationship, love each other very much, and we're just like everybody else. We want to find a cure to this disease. These people are all with me, my mom and dad, Taylor's grandparents, and some of his cancer camp companions.
We almost did not come to Dr. McLean because we were discouraged from getting a second opinion. Our doctor, well, we know what it is, we know how to treat it, we're going to use the LCH3 protocol, this is what we're going to do, here's your protocol. And I'm like, okay, well, if we're going to get the same treatment no matter where we go, then, a protocol is a protocol, everybody gets that, right? And we came down here and he did a totally different plan and put him on the RSC, which protects, or is thought to somewhat protect the neurological function, I was just stunned. I'm like, what if we had not done that in 10 years? You know, and then I met Taylor, and I'm like, this is what could, you know, not that we're out of the woods, but, you know, and I saw that, and I was so thankful that we came and got another opinion.
So Anton was born in 1998. He had a rash at birth. It was one of those rashes that I knew that wasn't a normal rash because it bled, and the pediatrician kept telling me, oh, there's nothing wrong. And I said, well, I know there's something wrong. Now, the dermatologist I'd taken him to had this very serious face when I brought him in, and wanted to do a biopsy that day, and I thought, that didn't sound good. And then sure enough, he was diagnosed with LCH. But luckily, he's been in remission.
So we were on chemo for about 4 months. In those days, it was get off chemo as fast as possible because the chemo is worse than I don't know what. But so we went off, and then he surged back. Remember that for a couple weeks, and then it tailed off again. And then we've been very lucky, but you know we still live on pins and needles.
When Anton went into remission, I decided, let's climb to the top of Half Dome to raise money for Anton's research.
We wanted to bring other families together.
Well, that's the next slide. Oh, okay.
Framework.
You can tell we're married.
We also wanted to do a kind of a fundraiser that others could replicate elsewhere, something that had some ability to scale.
That's good.
My daughter is Sophie, and she noticed a bump on her head herself and was saying, this hurts. Went through the different steps, pediatrician, skin doctors, just different things, and after a small biopsy, they still weren't sure exactly what it was, but we got referred here. Ended up removing the bump, the lesion. She called it Ouchie. She gave it a name so that she could identify. She's 9 now, and this all hit last year. We know we're in the best hands if anything was to come back. We just keep an watchful eye.
We kind of saw some diaper rash. I think a lot of parents, or a few parents I've spoken to, that's more or less where it developed. It just wouldn't go away, and something just kept telling my wife and I, you know, okay, this is something's not right. It just, you know, you get all these different ointments, and I mean, we went through I don't know how many different ointments, thinking, okay, this is going to work.
Ointments or creams or antibiotics is treated for all too long a time without being biopsied. It's very easy to biopsy the skin. Common things are common, and if they don't go away in a common, ordinary amount of time, then you need to think to the next step. And maybe one of our biggest challenges to educate the general pediatricians in the community about when you should go the extra step with a skin rash and refer to a dermatologist, and likewise for the dermatologist to say, well, okay, I've treated this for 2 weeks, 4 weeks, whatever, with cream, and it's not better, maybe I should do something else. It's frustrating to me that sometimes these stories extend for months when a resolution could have, or at least a diagnosis could have been made quite a bit earlier.
Oh, my name is Sean Paris. This is my beautiful wife, Leland. and she's going to tell you my story.
He woke up one morning and he looked at me and said his eyes felt funny. And once the doctor actually knew that the jerking eyes, which he diagnosed as nystagmus, was something that was new, he thought that Sean was born with it at first. And when I said, no, this was a brand new symptom that had just come on, he became immediately alarmed and wanted us to go get him tested for multiple sclerosis. And we actually met with the head of the neurology department. And
I was diagnosed with neurodegenerative central nervous system Langerhans cell histiocytosis with central diabetes insipidus and periodic alternating nystagmus.
We didn't even know what any of that meant. We thought his jerking eyes or nystagmus was his first symptom, but in reality it was diabetes insipidus. Diabetes insipidus is an excessive thirst and urination due to the pituitary gland being attacked. He would end up taking a medication, we just call it DDAVP, and his version was a nasal spray that he would take. And he was just Sean with DI from age 13 until 29 when he got the diagnosis of LCH. After it being undiagnosed all of this time, it actually possibly went down passageways from the pituitary gland down to his cerebellum in the back of his brain, and started attacking cells there. That's what caused the nystagmus. That's what also caused the ataxia, or the poor balance, poor coordination, and the thick speech. He had trembling hands. And so there was really just a slew of things that we were just being blind to because we just didn't understand the disease at all and what to even look for. He began chemotherapy, cytarabine. We went down to see Dr. Kenneth McLean, a specialist in Texas who is an amazing godsend for us. And he then recommended that Sean do 6 more months because just in that 6-month time period, Sean started deteriorating again. I wouldn't have wanted to do any of that stuff that they had to do. He had to give himself shots because I was like...
In the stomach area. They were long needles too. Wasn't a lot of fun.
No.
That was the Neupogen shot to boost my immune system. When I was diagnosed with this and had to go on chemo, I had to stop working. And because of the nystagmus, I had to stop driving. I don't talk nearly as much or as well as I used to. I do want to mention the hardest thing for me was being scared to go around my kids. If either one of them had a cold, I could catch that and it could turn into a life-threatening thing. So I was just absolutely terrified to be around my kids.
He would lay on the floor, curled up in a fetal position, and then my daughter would go and lay right next to him. And seeing that he would have to go through seeing that he was in such pain and trying to get better was really hard on a wife who can't fix it. And it's hard to see that your children have to watch it and that they don't understand it, but that they just accept it like it's normal. He wanted to fight for us, and he's done an amazing job so far, and we really just hope. We wanted to try something different, and here in Michigan we have a couple facilities around us that have something called hyperbaric oxygen therapy, and it's something that's, I don't believe, been tried for LCH.
But then it's been researched for a bunch of different issues, one being multiple sclerosis, another being traumatic brain injuries, and because of those two issues, that's why we looked into it for the LCH specifically.
Basically, you sit in a very large tube that is pressurized,
filled with 100% pure oxygen.
Yeah. The concept is that the oxygen would get into your blood and then into your plasma, and then it would start to produce red blood cells and stem cells, and the red blood cells carry the stem cells where they need to go. So the production of both of them is kind of important. Prior to hyperbaric, he was unable to do heel-toe, meaning place one foot down and then place the other foot directly in front of it and continue to walk in that fashion. 2 weeks ago, he did 26 steps and had to stop because he literally walked from one door to the other door and ran out of room. And he has less trembling in his hands.
Less eye movement,
yeah.
Which is, that's a blessing in and of itself.
Yeah. We document it each and every week. We take a video of him doing the exact same thing over and over so we can kind of compare, that we will really know if it's going to be beneficial for him, but also every other HISTIO warrior out there.
Hi, I'm Jeff Tohill. I'm president of the Histiocytosis Association. We started the organization in 1986 after my daughter Bethany was diagnosed with a form of the disease called Langerhans cell histiocytosis. Pulled a medical book off the shelf, looked up histiocytosis, and there was just one sentence: a rapidly fatal rare disorder. She had also developed a bone lesion on her skull, jaw, and leg bone. The oncologist put Bethany on chemotherapy. She's only about 3 months old at this time. 11 months later, they said, okay, hold your breath. We're going to take her off of it because this is not a cure. This is just something to stop the process. She's now 29, married, 3 children, doing fantastic. I tell many patients, families, when they call, that back then I felt like I was holding my breath and I was afraid to exhale. And I'm 29 years later and I'm still afraid to exhale. Until we find a cure, I'm not going to exhale. I'm going to keep working for that cure. At the time that she was diagnosed, I wanted the opportunity to speak with another family, but never had that chance. As a result, I ended up writing to every children's hospital in the United States and told them I wanted to form an organization to put families together. I speak to every family that calls the office, and because I've had the experience of knowing how it feels to have a child with a rare disease. It's cases all over the world, and actually I used to keep a pen map in my office, and every day when I received a new contact, I put that little pin up in the wall and look at it and try to make sense of it. But what I found was it just matches population density. I'd like to talk a little bit about the plight of rare diseases in general. There's about 6,000 rare diseases that have been identified in the United States. That figure changes a little bit from country to country. The rare diseases do not get a high priority for federal government funding. Those children or patients suffer just as much as those children or patients who have more prevalent diseases such as cancer or leukemia. Rare disease organizations and families have to take the bull by the horns and just forge ahead and fund research. We require that when we fund research that the results are published in medical journals. So scientists and physicians are learning more and more about this disease every day. The physician group, which is a separate organization, is called the Histiocyte Society. The Histiocyte Society is an international group of about 200 physicians that are studying these diseases. We organize their annual meeting. They meet annually around the world. Physicians and scientists come together to share information and learn from each other. In addition, they have several international research projects organized, clinical trials, together with us, form strategic plans for the future and how we can best find a cure for these diseases.